Alright, time for another DraftPhysics.com video presentation. Debate physics also, but nobody will debate subjects of physics. Just can't happen. No back and forth, no argument, counter argument, nothing. Just can't be done, apparently. So all it is a propaganda war. Everybody just throws their propaganda up, and at least I am playing their argument and countering it, but once again, I can't provide their absent and vacuous counter argument because they don't have one, because there's no good answer to any of the rhetorical questions I ask. There's no good answer to the why haven't they redone the Eddington experiment from space. There's no good answer. Absolutely, it's impossible to contrive one because there's absolutely no good reason you don't redo a flawed experiment. I mean, tremendously flawed. The guy wrote in his own journal, I wouldn't stake my life on these results. Well, anyway. So this Science Asylum guy just makes these goofball videos with this really goofball abstract physics, pretending it's all so common. Oh, it's just so sensible, this nonsense I'm preaching. And it's just a religion, frankly. It doesn't have any good foundations. The logic is putridly silly and stupid. And I'll just play it and show just how full of crap this physics is. How dishonest it is. I mean, frankly, it's so crooked.
Are these two situations equivalent? On the left, you're sitting on the Earth. On the right, you're inside an accelerating rocket.
Well, I can tell the difference. Now, the first thing they should say about gravity is this isn't that complicated a statement. I don't know why they can't say it. Gravity is pushing your electrons and protons. It's pushing on the smallest things that you're made out of, and every single one of them. They don't have to communicate. It's not like you're being pushed on the surface. Gravity doesn't push your surface and then force the push to go through the rest of you. The movement happens to every single little bit of you at exactly the same moment. So every bit of you moves. So no bits of you. There's not one part of you that's moving different than the other part. Where obviously when you're in the spaceship, the bottom of the ship is pushing on the bottom of you. It's pushing. Your head only gets pushed because it has to push through the rest of your torso and your spine and all your skeleton. Your head wouldn't move, without that pushing from the structure of your physical atoms having to push each other. So it's a completely different reason, The difference in the acceleration is being caused by completely different two functions. Now, yes, when you're on Earth, the force is pushing you down into the Earth, and it's a reflection, the Earth pushing back. It's not, the force didn't originate with the Earth pushing back. The force originated with your atoms being pushed into the Earth. So yes, and there's obvious differences between the two circumstances. They are only superficially similar. So we're back to wave, particle, and all the other crap where it seems like, it looks like, it seems like, and you don't have to scratch it very hard to find out how, no, it's really nothing like.
Either way, you feel your body pushing against the floor, as if there's gravity. It's impossible for you to tell the difference.
So again, whether you can, your sensation mechanism can tell the difference. You certainly can tell the difference when you're not on the floor, in the sense that all you'll see is the rocket moving. In the case of the rocket hasn't hit you're here, you're inside the rocket, and the rocket decides to move, and now the floor is moving towards you. All right. Well, that'll look the same as in gravity when you're falling, but they are different. So again, you're saying you can't tell the difference, but you can't be sure you can't tell the difference. You really can't. I mean, if you acclimate to the circumstance, the point would be is that in one case you are actually being pushed by the force of gravity, in the other case you're not. But yes, in both cases There's nothing in your body that has a differential. So your sensations require there to be a difference somewhere. Something has to change. It has to be something has to change. And in both cases, yes, because every one of your little bits is doing exactly the same bit, the same thing. All your little hunks of matter are being exposed to exactly the same circumstance, then they can't tell the difference. They can't tell something's changed.
Or is it? Hey crazies, what we're talking about here is something called the equivalence principle.
Okay, which is not very useful, frankly, because what does it mean? I mean, how far are you going to take this equivalency? I mean, it's a superficial equivalency, granted, but there are two different reasons why you're moving. In one case, a piece of matter has hit you and is pushing you. In the other case, a subtle force that you can't see, like photons, is impacting you and pushing you. Those aren't the same thing.
You're accelerating uniformly, any measurements you take will be physically equivalent to measurements taken in a uniform gravitational field.
Okay, and whatever this measurement means, okay? So if the measurement is I got a hunk of, I just put a piece of, half of a cow, okay, outside my ship, and now I'm going to crash it into another piece of something, a duck. It really matters which one of those two things is actually moving. So if I have a 100-pound weight on one ship and I have a 10-pound weight on the other ship, and I'm going to let them collide into each other, and I'm going to pretend everything's equivalent and I can't tell who's really moving and all this nonsense, well, the fact is the two experiments are going to be different. If you crash the heavy thing into the light thing, you'll get a different outcome than if the light thing is the thing actually moving and it bounces off of the heavy thing, which it probably will do. The universe will look different.
Of appropriate strength. It's one of the founding principles of general relativity.
It doesn't mean anything, so why is it a founding principle when it doesn't mean anything? What's the implication of it? What's the purpose of it? What's the point of it? It's not saying anything real. It's only a superficial cover for some notion that reality doesn't have real in it. yeah, but it does.
But is it true? And if it's not, does that make relativity invalid? We'll come back to both of these questions a little later. For now,
yeah, whatever. Duck them. It doesn't even matter. I mean, you're sitting there arguing them and then says we'll come back to them. No, you're making the arguments, okay? And your arguments are straw man and lame.
Now, I just want you to imagine you've woken up locked in a room. This room has no windows. You hear no sound. You don't feel any vibration.
Yeah, and so your whole principle relies on you being completely ignorant of reality. So, you have a simple circumstance, okay? Let's say you're on the surface of this little round thing here, and I spin the round thing. Do you think the whole universe spun? So if I asked you the question, what do you think really happened? Do you think you were on something that's spinning, or do you think the whole entire universe, made of a zillion, gazillion tons of matter, all of that stuff moved using an insane amount of energy, not incalculably huge amount of energy? Or did I just use a little tiny bit of energy and move this, rotate this? And we're supposed to play some game like we can't figure out I think it's probably pretty much guaranteed which one's going to be the truth.
You're completely isolated from the world outside. This is exactly the situation I've put one of my expendable clones in.
So this again, he makes these videos for 10-year-olds talking about complex subjects. So what's the point of this?
Great. Here we go again. This is going to be hilarious.
Yeah.
Where do you think you are, man? Well, I can't tell exactly, but I feel my weight against the floor, so I'm going to guess this room is somewhere...
I feel my weight against the floor. So what is that exactly? Are you feeling being pushed in, or are you feeling being pushed up? Which was the thing?
Where on Earth? Interesting. What if I told you you weren't on Earth? Oh, so I'm on another planet with the same gravity. Nope, you're inside a rocket, accelerating at exactly 9.8 meters per second squared.
So he's just said it, right? 9.8 meters per second squared. And now she's going to show that squared doesn't mean anything. So he just said for no reason except to justify the silly, 1/2 mv squared kinetic energy formula. Not because it's true, not because Newton said it, not because it's some kind of real thing. It's not any per second squared. Newton didn't say that. That isn't the description of it. It's just 9.8 meters per 1 second. That's all it is. It's a ratio. Period. So again, this is just where the lies start seeping into the physics. Like there's some bullshit reason why we do this. Why do we do this? Why do you do that? Why did you just say 9.8 meters per second squared? Because per second somehow means you square a number? It's idiotic. Because something can happen 500 times or 1,000 times or 1,000,000 times, you square it, and that somehow it conveys the idea? It's just nonsense.
Weird. I can't tell the difference. That's exactly the point.
Then the point is again just missing the point that we know there is a fundamental difference, and the gravity is affecting all of your little bits, and that's why you can't feel it. You can't feel gravity push on you because it's moving your sense organs at exactly the same speed and motion, so you can't tell the difference that something's changed. You can only sense change when something changes. Let's see, is there some way I can get rid of this commercial? Pause. Oh, I just hate this fake. Anyway.
That's exactly the point.
Hopefully.
The 9.8 meters per second squared is what we call the acceleration due to gravity.
So why? Why is it there? Why is the second squared there? He knows it's per 1 second. Okay? It's only 9.8 meters per 1 second. I can't have a second squared. I mean, squaring one would be ludicrous. If I said it was 2 seconds, then it wouldn't be 9.8 meters per 2 seconds. No, for per 2 seconds, it would be 19.6 meters per 2 seconds. So if I change the seconds into some other number besides a 1, I have to change the 9.8. So what is this except a lie? It's a piece of crap. It isn't a true statement. There is no such thing as a squared second. You can't square a frickin' second. There's no such thing. It's not a geometric reality.
On Earth, at least. It's a gain of 9.8 meters per second?
So he just said it. It's a gain of 9.8 meters per, and here's the magic, right? I mean, you can see that, right? You can see that fucking 1 sitting right there, can't you? Yes, you can see this fucking 1 right here. So what does it make? How does it make sense? 9.8 meters per 1 second. So why did you write it as 9.8 meters per second squared? Because even if there was such a thing as a squared second, squaring a 1 isn't going to get you anywhere. So what's the point of it? Oh, again, the point of it is to pretend there's some sort of reason to believe in this kinetic energy mush theory of free energy. That's all. It's a contrivance. It's contrived to force there to be some sort of connection between their broken, idiotic notions of reality. And it has absolutely nothing to do with being honest. Nothing. I mean, he's saying it right here. 9.8 meters per 1 second. I've been saying that over and over again. It's per 1 second. It's per 1 second. How can you... What's a squared 1 second? Nothing. So why the bullshit?
For every second of travel. For
every second, that's right. For every individual second, you get 9.8. You don't get any squared functions. You don't even get quadratic amounts. You don't get any of that crap. You just get the 9.8 of increase in your velocity. That's all you get. 2 seconds, you got 19.86. That's going to be the outcome. 2 units of velocity. You want to believe it's 4 units of energy. So that's why the square is there, not because it has anything to do with reality.
For some perspective, 9.8 meters per second is about 22 miles per hour, or 35 kilometers per hour.
Right, and the funny thing is you can also do these little number games and find out that, well, gee, it's about 1/20th of that, okay, is the velocity that you're actually being pushed into the Earth at. Because all I have to do is give an object, okay, horizontally, all I have to do is give an object 1 mile an hour of velocity, and I can make it weigh its weight. So with 1 mile an hour of force, okay, of velocity, any mass will weigh on a scale its weight horizontally, without the asset of gravity. So taking gravity out of the equation and just weighing things in empty space. If I weighed it in empty space, so far away from all the other planets, no influences. If I tried to weigh something in empty space, well, that's exactly what I do. I give it 1 mile an hour of velocity, and it will weigh its mass. Why don't you tell people that fact? I mean, it's a fact, okay? And it seems completely undiscovered by your physics, and it's the most elemental fact there could be. There can't be a much more important thing to say to people than, well, all you need is a velocity of 1 mile per hour to actually weigh your mass, to duplicate gravity.
Without air resistance, that's how much a falling...
Duplicate your weight, your static weight in gravity. Not your falling weight, just your static weight.
object speeds up every second.
So yes, and it speeds up and it gains twice the velocity and then 3 times the velocity and 4 times the velocity, and there is no quadratic, well, that's 4 times the velocity is 16 times the energy. Where did you show any of that? Is there any proof of any of that, little funny crazy guy? Do you have any evidence at all defending that mushy, silly nonsense? That as I increase velocity, I quadratically increase energy. That somehow it does more work. Have you ever shown the bullet knocking down more buildings than the recoiling guns? If I took all the energy of all the recoiling guns and all the energy of all the bullets, could I knock down more buildings with the bullets? Where did you do that experiment? Where did you even explain how that's no, the bullets will knock down 1,000 times more buildings?
For expendable clone to feel his weight against the floor, his rocket must share that acceleration.
So again, I don't even share. It's not sharing the. He must have. So he doesn't even say it right. Yes. So the rocket's floor must move at 9.8 for you to have the opposite of what gravity is doing. So yes, you want to create the opposite, then make floors move at 9.8 meters per second.
It's accelerating.
But what's the impact? The impact velocity is going to be 1 mile an hour.
Through deep space at the same rate that things fall toward Earth. What most of us call weight is just the feeling of weight. Now,
see, if you made the ship, if the guy actually was standing in the ship in the middle, and then you gave the bottom of the floor a 9.8 velocity, well, it's going to be increasing its speed, to get to 9.8. It's not going to, if the Earth hit you with 9.8 meters per second, that is, if it was going 9.8 meters per second, so to speak, the impact would be, like 10 times more violent than you're actually sitting in gravity. So he doesn't even get that part right. That you have to accelerate at the same rate that the floor is accelerating. If you allow the floor to accelerate to 9.8 meters and it hits you at that speed, it's going to feel a lot more violent than what you feel sitting in gravity. Because sitting in gravity, you're really only going 1 mile an hour.
The weight itself. Right now, you're feeling an upward push from the ground, or your chair, or...
I mean, I don't know what all this politically correct crap is. Well, whatever, diversity correct. So the animations are, people of diversity. It's just... it's just what is it's just everybody's just playing such stupid fucking games, especially in a physics conversation, right? Because we know that diverse people are so interested in the subject.
Both. You also have a weight pulling you down, something you never feel. Sure, that upward push only exists because the Earth is already pulling you down with gravity. But what if there was another reason?
Yeah, it's not like it's pulling you down, again, is this, the jargon. No, you're being pushed into the Earth, and the Earth feels the pressure, and the pressure builds up inside of the Earth, increasing its pressure, and it pushes the increase out.
For that upward push. Like a rocket, you happen to be inside, accelerating forward. You would feel a weight, even though you don't have one. But just because one situation is indistinguishable from another, that doesn't necessarily make them equivalent. There may be an upward push in both situations, but only one has a weight, right? We're not saying his contact with the floor is gravity, are we? The equivalence principle...
Yeah, who knows what you're saying? But I mean, the point is we can know the difference, because we can know that there is a difference between when the force I'm acquiring from gravity meets some other material object, that all of a sudden it can't see the force. It has to see the force through matter hitting matter. And it's that matter hitting matter thing, okay, is very different than a force hitting matter.
Seems to say so, but that's kind of sus. And a huge part of science is tearing ideas to shreds for the benefit of all humans.
It is? No, I don't, The whole point is to get to the truth, okay? If that's not your ambition, is to actually reason this thing out so you get the right answer. I mean, you're trying to figure out something kind of obvious, like is the crocodile's mouth really technically big enough to actually swallow my leg? So how much can we afford to give away? It's like you're doing some sort of boat engineering, Titanic thing, and there's a right way to engineer the boat and a wrong way. You're trying to get the right answers. You're not trying to get any answer.
Mankind. Whatever survives is the truth. Or at least...
I mean, it's just hilarious. So I'm giving you a clue. Here's a clue, fuckhead. Okay? Your theory of reality isn't going to survive. I'm sorry. There is no wave-particle duality, okay? Waves is bullshit. Waves are emergent. They aren't elemental. There's no elemental waves in the universe. They're only byproducts of patterns that are created by something that doesn't have any elemental wooey wave function. All right. And this crap, kinetic energy, is crap. There is no quadratic increase in your energy connected with velocity. It's momentum all the way down. So you got that one wrong, and this whole equivalency crap is just that crap. There's a real universe in 3 dimensions. All the space is fixed. Okay, things move real distances in that real space, and they move the real distances in real velocities, and there is no relativity shit, okay, where you can pretend any of this crap is real.
Approximately the truth.
And none of it's going to survive. None of your crap is going to survive. Truth does win in the end, and all of you clock-stopping archaicists who are just, hugging your totem poles of bullshit are just slowing the process down. You're just dragging human intelligence. You're just some fucking anchor that's just dragging through the concrete, slowing it down, because you have an attachment to absolute bullshit.
So let's see if we can find an exception to this rule. What if we bring in another object? Say...
Okay, so this is all the straw man stuff. Well, what if we do this? Well, why don't you do something that actually, gets to the point of relativity and this idea of absolutes. This idea that, oh yeah, I can spin this using almost no energy at all, or I can spin the entire universe using the most insane amount of energy imaginable. Which one do I think is realistically going to happen? I mean, the one that's a bazillion times easier to happen? Yeah, I guess that's the one that's probably going to happen.
A squirrel. From the comfort of our space station, we see a squirrel floating stationary in space. As the rocket accelerates upward, the squirrel slips through a hole and into the rocket. From Expendable Clone's point of view, it would be as if a squirrel fell from the sky into his room. It's a perfectly reasonable conclusion. Not only does the squirrel fall, but it falls in exactly the same way that it would if it were falling out.
So it's just kind of stupid to say the squirrel falls and all that crap, because what you really know is that the other body is the one actually moving towards the squirrel. So the squirrel there's no change until a material object shows up and hits it. The squirrel is not being affected by any force at all. It's just going to be impacted by a material object moving at 9.8 meters per second.
On Earth. It's as if there's a gravity acting on the squirrel, even though we know there's no source of gravity nearby. The equivalence principle still seems to hold up. What if we have the squirrel come in from the side instead? Let's say the squirrel is moving in a straight line sideways. As the rocket accelerates upward, the squirrel slips through a hole in the side of the rocket. Expendable clone will see the squirrel enter his room from the wall and then fall to the floor in an arc, as if there was gravity. If we could see inside his room, we'd see the squirrel still moving in a straight
line. So again, who is this video for? You know, I'm just saying, I mean, he's dealing with a complex concept of relativity, and he's doing it in this, with this. Is this for what, 10-year-olds?
Line. It would be the floor accelerating upward. But according to my clone, it's the squirrel that accelerates downward like a...
Let's debate, you know, the theory of relativity in the 4th grade. Does that make sense? That's where the debate should happen, is in the 4th grade. It's a 4th grade class subject. Shit.
Projectile. To him, it looks like there's gravity. The equivalence principle still holds. I think it's time for something a little more extreme. Let's say his rocket is like 20 miles long and he's running up the stairs. Every 10 floors or so, he stops to measure his weight with a bathroom scale.
So now he's just going to play the game that's a changing gravitational field, right? But that's not what the frickin' statement makes, is that it's a constant. So you don't have a constant if you're allowed to change your elevation. So that's really not the equation. Yes, you can tell if you're in a gravitational field. As you move through the field and you change how much gravity is affecting you, you will be able to tell the difference. So yeah, so the equivalency principle really is just basically about how precise our instruments are. So it's basically saying if you don't have a microscope, you won't be able to see the microbes. You know, but you can deduce their existence. But yeah, you won't be able to see them. So because we can't measure the difference in the gravity here from here, right? The Earth is applying a different amount. It's 9.8 meters, that, you know, 0.0000 whatever. This is different. You know, the further out I go, the less gravity there is affecting the object. So, but we can't measure those differences. So the only reason why this argument is valid is just because we can't see, we don't have detectors that can detect that subtle difference. But as soon as we have those detectors that can detect that subtle difference, then all of a sudden the equivalency principle is blown up. Because there is no such thing as a constant field of gravity. That's the whole nature of gravity, is that it's not constant. The photons, the closer I get, the more photons that hit me. The further away I get, the fewer photons that hit me. It's just a fact. There is no constant place. There's just one single place.
No matter what floor he's on, his weight will always be the same. That wouldn't be true with a 20-mile tall building. In that case, your weight would gradually decrease as you went up floors. Your weight on the top floor would be 1% less than your weight on the bottom floor. Bingo bango, equivalence principle broken. Wait a minute, that's not a uniform gravitational field. Ah, crap! This principle does require that gravity be uniform. And that's only approximately true.
Yeah, and again, there's no such thing. There's no such thing as a uniform photon field. There's just no such thing. Except in one location. So yeah, if you just say you can only do this experiment in this one place in space.
Near the surface of the Earth. If you get far enough away, we stop being able to make that approximation. Not only does gravity get weaker with distance, it can also turn. Down is toward the center of the Earth, which isn't always the same direction. Earth is round, and sometimes we have to account for that.
So this is another one of these points where they're just, again, so subtle, but it's true, okay, that things that produce gravity are matter in the universe, and they produce it from a theoretical center. It really doesn't have anything to do with it. It just has to do with when you add up all the pieces that go through parts of the Earth, they all add up to being in the center of the Earth. But that's just something to do with how circles work.
Really long bridges are a good example. If we were to drop two squirrels a mile apart and from a mile high, they'd be 1.3 feet or 40 centimeters closer together by the time they hit the ground. Which is yet another situation where the equivalence principle does not apply. If the accelerating rocket was a 1 mile cube, the two squirrels would stay exactly 1 mile apart the entire fall. The equivalence principle only compares uniform acceleration with uniform gravitational fields. But it was never meant to be a universal law.
So there we go. So now he's just saying it wasn't meant to be a universal law. So it just basically pointed out a circumstance where artificial gravity that is created by a spaceship isn't going to have a center from which the force comes from. And so therefore it will be noticeable. But he's just changing the rule now. Well, but that doesn't matter.
Its purpose is to help us design thought experiments so we can ask the right question.
Oh, brother. So the thought experiment is why do you have not a single bit of any evidence anywhere on this planet documented ever that it takes 25 times the fuel to go 5 times as fast, or that something moved at 5 times the velocity does 25 times the work? Why don't you just explain how kinetic energy moves spaceships? That if I throw squirrels out of my spaceship with different kinetic energies but the same momentum, why don't you explain to me how those different kinetic energies, why they don't move my spaceship? You don't do any of this science thing, do you? It's just this whatever theater you're putting on your stupid little puppet show.
The experiments in this video seem to suggest that gravity is simply acceleration we can't see.
Oh, wow, bingo. We can't see a lot of things, right? We can't see photons, right? I can't see them go by. I can't see photons, all right? I have to wait till they hit my eye and explode, cause momentum transfers. So it's only when there's a momentum transfer can the thing be noticed. And that's what happens with gravity. You only notice it when it creates a momentum transfer.
Since they only happen in our minds, they can't tell us if that conclusion is true. But if it is true, it can tell us what consequences we might see.
Blah, 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 blah. So again, now we're back to relativity. And again, the fact is that if it's an absolute universe, it is in some ways detectable. And Newton tried to deal with that with the Newton's bucket thing. And you really don't have any good explanations. Any good arguments against the idea that all I have to do is spin something in the universe and I can be pretty goddamn sure the whole universe didn't start spinning.
Remember when we had a squirrel enter Expendable Clone's room through a wall? Well, what would happen if a pulse of light entered the room instead? It would also...
Well, there's lots of wacky people who say it'll shoot forward and hit the target on the side of the wall like you didn't move the wall at all. That's what they say. They say the light somehow will know it's supposed to go forward.
Bend toward the floor like the squirrel's path did. Just not nearly as much.
Yeah. Well, much relative to what? But that's the big joke, right? It'll bend towards the floor for a good reason, because the floor is moving up. And there's just no choice but for it to look like it missed the target, because the target's up here and the light's down here. The target moved up the wall while the light was going across. It misses the target, but obviously just like the squirrel, the light didn't change. The light's a dead straight line. This never happened. The light never did this bending thing. The wall merely moved. So, if you draw it the right way, it's perfectly understandable. Nothing got bent. The light doesn't bend. All right. And obviously, I would argue that
the bend would be subtle because...
And the fake here is that they're not going to be able to match this, because they're going to he's basically going to argue that the amount it bends is going to be twice the amount that everything else bends. Now, why would it bend twice the amount that everything else bends? Why would light bend more than the squirrel per mass? Why?
Light is fast. Fast. If we believe the equivalence principle, and we haven't found any reason not to.
Well, except logical reasons. That it's harder to move the entire universe than it is to spin this in a circle.
Then that means light should be affected by gravity, just like squirrels, which seems absolutely bonkers.
No, it seems just silly, okay? Because first, the light wasn't affected by the spaceship. It went in a dead straight line. And second, no force is affected by another force. You can't bend light with a piece of light. I can't use light to bend light. If light can't bend light, then why should I think that light can be bent by something else even more discrete?
Reason people didn't believe Einstein and Hilbert when they published this in 1950. They had to actually prove it.
So again, this is the scary part, that this asshole knows it's a shit experiment. Okay, there's all kinds of doubt in it. Now, maybe he doesn't know that Eddington said in his journal, I wouldn't stake my life on these results. And maybe he doesn't realize that Eddington said right in his journal, I'm expecting 10,000 stars in my glass slide. 10,000 visible stars. And he got 1,000. I mean, that is a 10%, a 90% degrade in the data he was using. This was already a really difficult experiment, really hard to do. You know, really dicey. You know, tiny little margins of error, blah, 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 blah. And he got data that was 90% shit. I mean, 10% of what he was hoping for. 10%! That's the reality that you're lying in defense, okay? You're just telling a story about how they prove something. That's not a proof. That's not the definition of a great scientific experiment. The guy says, I don't trust my life on these results, and I got 10% of the data quality. And this asshole is basically just saying, well, that's just fine. That's a great experiment. Yes, let's call that proof. That's good science? That's just lie science.
Which means they had to wait for a total solar eclipse and for World War I to end. Europe
and but since 1969, pretty much we've had this real easy ability to just take a snapshot. You know, we have 400 times better resolution from space. That is, you need 400 times less of a telescope. 400 times is 400 times bigger and 400 times smaller is really big. That's a really huge amount of difference. Yeah. And we never did the experiment from space. That's right. We never repeated one of the most famous experiments in the history of science, and we never repeated it from space with 400 times better resolution. You don't need an eclipse, and the experiment takes 5 minutes. And we're supposed to say, well, yes, that's very good science. Yes, science doesn't do experiments. That would be a terrible waste of time. An experiment? Phew. Especially when it takes 5 minutes? Holy shit, no way we're doing that. A five whole fucking minute experiment? Holy and I need a GoPro camera? Oh man, I'm not buying a GoPro for that, for science. No. I won't spend $300 on a camera. I'll spend $3 billion on an accelerator instead.
Was leading science at the time, and they were understandably kind of a mess. Anyway, the idea is that if light from a star passes close enough to the
and Einstein himself speculated about using Galileo instead. I could actually use a planet. Because guess what? The sun is a big ball of shit, okay? It's hydrogen. All right, it's really light and fluffy. It doesn't make a whole lot of gravity. I mean, as much as it's just, it's only making a huge amount of gravity because it's absolutely 1,000,000 times bigger than the Earth. I mean, they draw these pictures, but the sun's 1,000,000 times bigger. Okay, but it's incredibly light, so the surface gravity sucks. It's only 80 times what the Earth's gravity is. And obviously you can't even do the experiment out anywhere near the surface because there's so many flames flying out and there's all kinds of ions and all kinds of gases and all kinds of shit flying out. So you have to do the experiment way out here where there's only like 30 times the Earth's gravity or 20 times the Earth's gravity. So yeah, it becomes real viable to go out to deeper space where you have nice cold planets, okay, where you don't have to worry about the big flames flying out and all that kind of crap. So yeah, I mean, the fact is, Einstein talked about Jupiter being a possibility, but it was only negated as a possibility because, yeah, he didn't think of doing it from space because obviously we weren't in space yet. Okay, but yeah, he would be able to say to you, hey, but wait, if we could, do the experiment from space, yeah, 400 times better resolution. Jupiter is easy now. Go ahead, do Jupiter. Use Jupiter. It's nice and quiet, no distracting blobs of flames flying out. Yeah, do that. And they never even did it. So again, don't tell me this is science. This isn't science. This is just such fucking propaganda. This is just goddamn totem pole describing. They're just talking about their favorite totem pole, and this is their favorite little, gimmick and animation and little fun talk, but it's all that. It's just trivial little kid shit. This isn't science.
Sun on its way to Earth, then the sun will bend its path, making it appear in a slightly different location in the sky. And I mean...
Yeah, right. So he means slightly. And yes, Eddington got 10% of the data, so it's really hard experiment to do, and he only got 10% of the data quality. The image was I mean, 90% blurry. I mean, that's all. What do I have to say to you? It was a Sasquatch picture. I mean, it was 90% fog and 10% stuff.
Slightly. They estimated the deflection angle to be less than 2 arc seconds. That's less than 1/1800th of a degree. The US tried to do the experiment in June of 1918 in Baker City, Oregon. That was near the end of the war. But alas, it was cloudy with a 100% chance of failure.
And 3 years ago, whatever it was, 4 years ago, they had a perfect eclipse over North America. Perfect. 12 noon eclipse. Eddington's eclipse wasn't even 12 noon. It was like 1:30 in the afternoon. It wasn't even a perfect eclipse. I mean, you want the shortest distance through the atmosphere as possible. So you want the sun to be as straight up as possible when the eclipse happens. So all these are factors. None of these stuff is talked about. This whole experiment is a big fat fraud. And they again, we're supposed to believe in the 50 years we've been in space, it's never occurred to any NASA physicist to say, well, let's spend 5 minutes doing the Eddington experiment.
The next total solar eclipse?
With 400 times better resolution. We could, they could take really high definition, high quality images.
Wouldn't happen until May of 1919. European scientists planned out 2 expeditions. One for Sobral, Brazil and South America, and the other for Principe in Africa.
Right, and they had to take 12-foot long, 12-inch telescopes, okay, and haul them to these locations, up mountains to get out of the fog and the bullshit. I mean, not great scientific conditions.
The hope was that at least one of them would get decent images, and after some technical difficulties, both teams managed it.
Now, it's just a lie. So again, so it just didn't happen. That didn't happen. All right, that's just a lie. It didn't happen. Eddington didn't get any good images in Africa. None of them were great images. None of them had 10,000 stars. None of them did any of that stuff. So that's just bullshit. It was flawed data from both locations, and the fact is, it's a shit experiment.
Here's one of the images from Brazil. The results of this experiment...
Well, that was great. Didn't that just prove everything to you? Yeah, that's all I need to see. That sure proved it. Shit.
Confirmed that prediction from General...
Confirmed. So, yes, that the light squirrel is bent twice as much by gravity. So photons are magically bent twice as much as squirrels.
Or relativity. Light is, in fact, affected by gravity, just like squirrels.
So he just said it. It's a fact, and your evidence absolutely sucks. You never repeated the experiment. You've never done a visual experiment. You've never done an image-producing experiment. Instead, you just sit there and bounce off the fog around the sun, or through the fog of the corona. And then pretend you don't know that, well, that means the light will get bent in all directions. And so, yes, it'll take the shortest path and it'll take the longest path. I can just find whatever path I want.
As far as we can tell, gravity is just acceleration we can't see.
So again, more nonsense. But of course, it's acceleration we can understand. And we can understand it because other things do the same thing. Photons, other invisible mechanisms cause effects, cause matter to move.
The equivalence principle might not apply to solar eclipses, but it did...
Might not... why did he just say it doesn't apply to solar eclipses when he just said, we just proved that the photons are bent? I don't know.
Present us with a thought experiment, which led us to conduct a real one.
Okay, led us to do this, to do that. So again, just more bullshit. And again, can you get any clearer than the guy writes in his own journal, I wouldn't stake my life on these results. He describes all of the failure of the experiment, how it just couldn't go much wronger. Okay. I mean, it was actually raining 10 minutes before he was taking his pictures. So you can imagine it wasn't a beautiful blue sky.
Experiment we never would have thought to do otherwise.
Even the water molecule still in the atmosphere would have been a problem. Even if it was a blue sky, it would be a blue sky full of water molecules that are fucking up your seeing.
So is the equivalence principle true? Yes.
Oh, fuck you.
Is it universal? No.
Oh, whatever that even means. But yes, what is the principle that there's no difference between a force moving your individual electrons and protons with this, with with stuff moving the speed of light, and that each little bit is moved, and the difference between somebody punching you in the face and moving part of you. Those two things are the same. Well, they're really not the same. There's no point in calling them the same. It's just kind of ridiculous. Well, it is ridiculous.
But that doesn't mean it hasn't been extremely useful. And until that...
Oh, yeah, it's useful for what? Keeping you all with your heads up your ass, thinking, oh, I know the special code. I know what that forky symbol means. Forky symbol divided by, the little screwy loopy thing. Squared. Per second. Whatever. Fuck. Science. What a pile of shit. Frankly, it's just shit. And you people just eat up the shit. You're just poo eaters. Ew. I'd be embarrassed to walk you down the street. Frickin' poo eaters. Ew.